Hello everyone, so we continue our conversation on aqueous equilibria, and in this example we're talking about different ions that are in solution. So we're looking at three ions, Fe2+, not 3+, there's a typo, Pb2+, and aluminium 3+ in the laboratory. And we're told that this solution contains all three of these ions at 0.1 molar. And then we're asked, in what order will the hydroxides of these salts precipitate as aqueous sodium hydroxide is added? Right, so sodium hydroxide will be a source of hydroxide ions. So what I've gone ahead is I've written the solubility equilibria for each of these salts with hydroxide. So the hydroxide salt, so meaning iron hydroxide, lead hydroxide, and aluminium hydroxide, will be in equilibrium with the hydroxides, of course, on the right hand side, and the metal ions and their KSPs, as well as their KSP expressions. So as you see, the KSPs differ and the KSP expressions differ, so quite interesting. And because we know they have the same concentration in terms of the metal ion, it means that depending on how much hydroxide we've added, we will have a situation where we have fractional precipitation. Right? So one of these, so as we start adding sodium hydroxide, depending on their KSP value, one of these will start precipitating first, and then the next one, and then the next one, because they're not equally soluble. All right, so let's go ahead and calculate when these will start precipitating. So in the first case, we will find that the iron hydroxide salt will precipitate when we reach a hydroxide concentration of, so we need to solve KSP, right, divided by iron, Fe2+, and we see we need to take the square root of this because it's iron OH squared. So you can put in those values, and iron 2+'s concentration, of course, is 0.1. So the KSP is 4.9 times 10 to the power minus 17, 0.10, and I get the relative value here of 2.2 times 10 to the minus 8 molar will precipitate iron 2 hydroxide. All right. So this, at the moment, it doesn't really mean anything to us. We need to look at the others as well. So what is the value of, or the concentration of hydroxide that will precipitate lead hydroxide? So if we solve here for the hydroxide ion concentration, the KSP here is again the square root, and this time over the lead ion concentration. So KSP of the lead ion, and the KSP here is 1.4 times 10 to the power negative 15 over 0.10, and if I round this, I get a value of 1.2 times 10 to the negative 7 molar, and that, once that concentration is reached, we will precipitate the lead hydroxide. All right, so now we can start to see, all right, we require a lower concentration of OH to precipitate the iron hydroxide than the lead hydroxide. Cool. So let's look at the last option. And what concentration of hydroxide will precipitate aluminium hydroxide? And we see here we need to take the, we need to take the cubed root of this situation, KSP, divided by the concentration of aluminium 3+. Right, we solve that for the hydroxide, and we see that. Interesting. And the KSP here is very small now, 1.3 times 10 to the negative 33 divided by 0.10. And this gives also a very small value, 2.4 times 10 to the negative 11 will precipitate aluminium, let's put aluminium hydroxide. Alright, so what does this tell us? It means that the salt that requires the lowest concentration of hydroxide is aluminium hydroxide. The one that requires the next highest is the iron hydroxide, and the one that requires the highest concentration is lead hydroxide. And therefore, the one that will precipitate first is aluminium hydroxide. Right. Why? Because it requires the lowest concentration. Which is followed by and finally what is that? Lead hydroxide. Why? Because the one that requires the smallest amount of hydroxide will precipitate first, because it means it requires the least amount of hydroxide to be added before it forms a precipitate. Now, one that requires the most will have to wait until the hydroxide concentration builds up the most before it will form a precipitate. All right, and that's also then again how you can separate them. So once the aluminium hydroxide has precipitated, you can filter it off, completely remove it, and then get the next precipitate, remove it, filter it off, and so on and so forth. Alright, so good way to separate ions and remove them from solution as well. Good. Thank you for watching, and I'll see you in the next video.